we'll get into that. Actually, before that, we're going to do some examples. Answers are already up here, but I would like someone to explain things from them, okay? So, Tamara, for A, how many different types of hydrogens are there?
4.
Right.
Huh? How many different hydrogens?
Types.
Oh, types. Oh, 2.
2. And
I'm sorry.
so we have A and B that we already labeled for that. Which one would be upfield and which one would be downfield?
A would be downhill and B would be uphill. And because of, you told us that CH is considered a non-withdrawn.
Yep. So, look at the carbon that it's attached to. This carbon is directly attached to 2 points. Therefore, this one will be downfield. This one is attached to this carbon, and then, so it's twice far away. So, what about this one? Yeah. Sorry, Michael?
Probably got me.
Matt.
Okay. D? How many different types of hydrogen?
How many different types of over there?
3. A, B, C. And which one will be, like, predict the order of these?
We go to ABC, farthest to
So A will be higher, or lower?
higher.
Higher. Everyone agree? Because this one is the closest to the bromine, so this one will
So-
be around 4 maybe. Then this one is semi-close, and this one is farthest. What about numbers?
I have a question. If you had to identify, because A would be downhill, C would be uphill.
Downfield.
Huh?
Field, not hill.
Oh, downfield?
Yeah.
Thank you. I thought you said downhill that whole time. We've been putting downhill.
Downfield.
Okay, what is C?
That's the next one.
What is C then? I mean B. B would be considered.
Oh, it would be
In
between.
between.
Is there a word for that? Okay.
Is it downhill or up?
It's downfield. Yeah.
When you're saying A is downfield, but you're saying that one will have the higher.
Yeah, so higher shifts are called downfield.
Okay. So C would
A
be.
would be downfield, B would be between, C would be upfield.
And
But-
it helps you guys remember downfield is to the left and upfield is to the right on the graph. If that helps you.
Field.
Field,
not hill.
like running in a field, not running down a hill.
Okay.
Field.
I'm running a field.
Do you have a question?
Oh no, yeah, it's okay.
Okay. So, what's happening with numbers, not numbers, letters?
They're all.
You gonna have a plateau?
Yeah.
Is it gonna go like this? And is it gonna like real high and then it comes down like a plateau?
We're not
Well,
talking
you-
about heights yet, we're just talking
Oh.
about where it's coming.
Okay. Hey. I'm just saying, man.
This, see?
You got 3 of them that's the same, so I think it would go something like this.
Yeah.
And then
Chemical shifts.
It's just her face is funny. She's
C would be, have a lot of CH groups, so it's hard to predict the order
how you think we feel?
without actually looking at it. So what's coming first? Yeah, right?
Because A only has 1 carbon attached to it.
Is it on circle?
So someone tell me why these two are equivalent.
Is it in a circle? Is it in a ring?
CH2.
Is it in a ring?
Time.
Is it in a ring?
No.
It's not a ring.
No.
Shit, why not?
It's got CH3s on both ends.
I understand that, but I thought the A's would go together. Hey, I don't know.
Because they're attached to 3 hydrogens and a carbon.
Yeah, so look at the environment, right? So what you should look at is the hydrogen. Look at what that carbon is attached to. This carbon is attached to this group. This carbon is attached to this group. They're both the same. Therefore, these two are equal. Look at this one. This is attached to this carbon and this
See, I
carbon.
thought that said
This
D.
carbon is attached to this one and this one. And therefore, they're attached to the same kind of things. They're the same. This one only has 2 carbons, and these groups are also the same. Therefore,
tell the difference like between like which one hydrogens are different? You just look at the environment that they're
Yes.
in.
Look at that carbon and what that's attached to.
So it's kind of like assigning priorities again. Kind of like that. Okay.
So you would say downhill, uphill, or shoot, downfield, upfield, downfield.
I would say downfield and it gets upfield. So C would be like around maybe 1.5.
So we're moving this way. We're moving this way. Okay, so it would be downfield, upfield, downfield.
Why were you putting this one downfield?
C,
C would be the first down.
C is farthest down, B is in the middle, A is farthest upfield.
So A
Oh,
has the
so you don't group
highest shift
You say you don't do
volume.
this.
Smallest.
Or sorry,
You don't
smallest.
group them. Because she said they were the same.
Same.
But then why wouldn't?
But you
I
put them
mean,
on one plane.
how many peaks would you get? 3?
3.
That's what I'm saying.
One of the other things that's tricky about NMR is if your hydrogens are next to other hydrogens
This would be
that are not
downfield.
then it will split itself into
So that's
certain
right.
peaks. Okay? And we rule that you have to pay attention to this n plus 1. And again, examples will be more useful than the definition. So in this case, I'm going to explain what's happening. We have this orange hydrogen, and in this molecule we have 2 different types of hydrogen. 3. Okay? And so this orange hydrogen is attached to, so you look at that carbon, 1 carbon over is attached to 3 different hydrogens. Okay? So 3 plus 1 is 4. Right? So this hydrogen peak will be split into 4 different lines. Right? And so between A and B, which one will be down? A, because that carbon is attached to chlorine, right? So right here you see 1, 2, 3, 4. Okay. Likewise, we look at these hydrogens, go 1 carbon over, see how many hydrogens that carbon has. 1. So 1 plus 1 is 2. You expect this to be upfield. 1, 2. Okay?
What would we explain it?
Yeah.
One more time.
Mm-hmm.
So 2 different types of hydrogens. The
Yes.
orange one and the red one. Alright, so let's start with the orange one. We know that will be upfield, so it's going to be much higher than we're going to do red hydrogens. You go 1 carbon over. Look at how many hydrogens that carbon has. Okay? In this case, we have 1, 2, 3, and plus 1, 3 plus 1 is 4. Therefore, it's split into 4. Okay? This one has, go 1 carbon over, it only has 1 hydrogen. 1 plus 1 is 2. Therefore, it's split into 2. Okay? Yes.
Why are the 4 peaks, why are like the 2 outer ones a lot shorter than the others?
Great segue. So, the last thing that you need to know is how many hydrogens come in for each peak, right? So remember your GC is the area that told you to develop the middle virtual, so it's the same thing that you have to do with this. So these numbers here are called integrations, and that number will represent how many hydrogens are, okay? So in this example, how many hydrogens are for A, the orange one? 1, and how many would you expect for B?
3.
3. And the numbers showing you here are 11.5 and 35.1. That's not right. So just like you did in your GC, you're going to divide this by 11.5, so you get 1. You would divide this by 11.5, and that matches the structure. So these are just ratios. They could be any big numbers, any decimal numbers. They won't be decimals. Okay. Well, basically, you have to divide and make a number that makes sense to fit your program. Okay. And usually, if you divide the lowest number by itself, then this.
Question?
Yeah.
What if you have 3 carbons in a row? Are you going to count both sides?
Yes. So we're going to do a lot of examples. You should be a pro by the time you leave. I already talked about this. So what I was saying earlier is just within words. Okay, so let's go on to our worksheet. So question 4 is easier to do than question 3. So let's do that. So Philip, can you come up and draw the first compound that we talked about in question 4?